Write a compound inequality. The recommended air pressure for the tires of a mountain bike is at least 35 pounds per square inch, but no more than 80 pounds per square inch. If a bike's tires have 24 pounds per square inch, what is the recommended range of air that should be put into the tires? So for this word problem, our first step is to define a variable. And so we're going to let x be the amount of air put into the tires. And we're going to write our inequality. And the inequality should start with the range at least 35 pounds per square inch. So that means 35 is going to be less than or equal to x. And that is going to be less than or equal to 80. So this is the recommended range for a mountain bike, where x is greater than or equal to 35 pounds per square inch, and where x is less than or equal to 80 pounds per square inch. And there's an and here. 35 is less than or equal to x, and x is less than or equal to 80. However, this problem states that the bike's tires currently have 24 pounds per square inch. And the question is asking, what is the recommended range of air that should be put into the tires if the tires currently have 24 pounds per square inch? So what we need to do is take this recommended range, and we need to subtract 24 from the low end, and we need to subtract 24 from the high end, because the bike already has 24 pounds per square inch. So now that we do the subtraction, we are going to be left with 11 is less than or equal to x. That is less than or equal to 56. So this here is the range of air that needs to be put into the tires. And of course, we're talking in units of pounds per square inch. Pounds per square inch. And so what we need to do to stay in the recommended range of 35 to 80 is to add to the tires that currently have 24 pounds per square inch a range between 11 and 56 inclusive. So let's go ahead and move on to the next problem. We have the speed is posted by a sign that says that the speed limit has a minimum of 40 miles per hour and a maximum of 70 miles per hour. Now we can go 40 miles an hour and still be within the speed limit, and we can travel 70 miles per hour and we could still be in the speed limit. So for this inequality, we need to include 70 and include 40. So what is the inequality going to be? On the low end, we have 40 miles per hour. So that needs to be less than or equal to our current speed. And that's going to be less than or equal to 70, maximum speed. So as long as our current speed falls within 40 and 70 inclusive, then we are traveling within the speed limit. And of course, when we have a word problem, we want to start by defining our variable. So let's go ahead and do that. Let x be the speed of the car. So now let's graph it. So we're coming over to our graph, and we have two separate inequalities. Let's go ahead and separate them now. We have 40 is less than or equal to x, and x is less than or equal to 70. When we graph, I like to have my variable on the left side of the equal sign. So I want to say or x is greater than or equal to 40. So let's go ahead and start with this inequality here. We have 40, and we have a closed circle, which is moving to the right. I'm sorry, I'm going to use pencil here. And then in our second inequality, we have a closed circle on 70. And our arrow is moving to the left. So if we have an AND, we need to graph for where both the inequalities are true. So 40 is true. All of the speeds between 40 and 70 are true. And 70 is also true for both inequalities. So this here is our graph of the compound inequality. 40 is less than or equal to x, less than or equal to 70.